In this lesson, you will learn how to solve a system of equations using the substitution method. Let's take a look at some notes and examples to better understand this concept. Solving systems using substitution. Before we go through the steps for the substitution method, let's first take a look at what the problems might look like. So as we look at this first example, it tells us to first graph this system of equations to solve it, and then use the substitution method. So you will notice that these two equations are repeated over on the right. So we will use the graphing method on the left, and we will use the substitution method on the right. To use the graphing method, we must first solve the first equation for y, to determine the slope and the y-intercept, to graph the equation. The second equation we can simply graph. So let's go ahead and solve the equation on the left for y. To solve this, we must subtract 3x from both sides of the equal sign, leaving us with negative y equals negative 3x plus 0. Then we need to divide everything by negative 1 to finish isolating the y. So our equation would be y equals 3x plus 0. So our m, or our slope, would be 3 over 1, and our y-intercept, or b, is 0. So let's go ahead and graph that information. So starting with the y-intercept, we're going to graph a point at 0. Then because our slope is 3 over 1, we're going to go up 3 and to the right 1. Or we can reverse those directions and go down 3 and left. And then we will again make sure we draw as straight of line as possible. I know mine is not great. Okay, let's now do the second equation, and I'll do that in blue. Y equals 6. Because there's only one variable, and it's a y, our line only has a y-intercept, which means it will only touch the y-axis. So we're just going to go up to 6 on the y-axis, and we're going to draw a horizontal line. And that is the line of y equals 6. Now, can you see the point of intersection? Hopefully you can. So our solution for this one would be 2 for x, and then if you count up, it would be 6 for y. So the question is, what if we did not have a graph, yet we wanted to find the solution, or the point of intersection? Well, there's a method called the substitution method that will allow us to find this same solution without graphing. In the substitution method, we want to first look at both equations and identify which equation is already solved for either the x or the y. In this case, the second equation is already solved for y. So we know the y value is 6. So in our solution, we can actually go ahead and put 6 as our y value. And if you go back to the graphing method, you will notice in the final answer, the y value is 6. So now to find x, we will simply substitute the 6 into the y of the first equation, because we know that the value of y is 6 according to the second equation. So we're going to replace the y with 6, and notice we now only have one variable. So we will go ahead and solve for that variable. So we're going to add 6 to both sides, and then divide by 3. So our x equals 2. So our solution is 2, 6, and if you go back again to the solution we got from graphing, it was also 2, 6. So we were able to get the solution without actually graphing the equations. Now this is a very simple and the beginning stages of the substitution method. So in a future lesson, you will learn about the substitution method using equations where they both have two variables. But let's continue with some additional examples where one of the equations only has one variable. So let's scroll down to example 2. In example 2, again, you want to first look for an equation that is either solved for x or y. Notice in these two equations, neither equation is solved for x or y. But it would be very easy to solve the second equation for x simply by dividing both sides by 5, which would tell us that x is 3. So if we know that x is 3, we know half of our answer. So to find the y, we simply need to plug the value of 3 in for x into the first equation and then solve for y. So we would have 3 minus 2y equals 0. And now we will solve it for y. Subtract 3 from each side of the equal sign, which leaves you with negative 2y equals negative 3. Then divide both sides by negative 2, and y equals 3/2. So our solution is 3 3/2, or 3 1/2. Let's take a look at example 3. Again, if you look at both equations, neither equation is solved for either x or y, but the second equation can easily be solved for y by dividing each side by 3. So y equals negative 4, and this would be half of our answer. Now we take that value and plug it in for y in our first equation. So it'd be 2 times negative 4 plus x equals 4. So we have negative 8 plus x equals 4. And if we add 8 to both sides of the equal sign, then x would equal 12. So our solution would be 12 negative 4. And this completes the lesson on solving a system of equations using the substitution method.